Melissa Griffin and I'm with WeatherSTEM. Today we're going to be talking about upper air observations and how they relate to weather forecasting. And we're going to start by talking about the surface observations and how those upper air measurements that are going to be made by our weather balloon help us here on Earth. We'll first take a look at all of the observations that are currently at Buck Lake Elementary School. You can see that the current temperature is 84 degrees. Our sky camera shows us the picture of cloudy skies, and we are looking at a relative humidity of about 33%. All of these surface observations are important, but there's something else important going on, and that's actually understanding what's going on throughout the entire atmosphere. And knowing this is going to be very helpful when it comes to knowing how to forecast what's going to happen today, tomorrow, and even into the next couple of days. Observing the sky is very important, so we're going to take a look at the sky video from Buck Lake Elementary School. This video is a compilation of all of these pictures that are taken over the course of the day, and we overlay that with our weather data. As we can see, clouds move in and out of the camera, which can give us indications of how the wind is moving in the upper atmosphere, and how those wind patterns may relate to the temperature, relative humidity, and dew point that we measure here on the surface. And as the day progresses, we can see temperature rises throughout the day, and once sunset comes along, we can actually see the temperature start to decrease. This sky video is from Buck Lake Elementary, but we really encourage you to look for the WeatherSTEM station that's closest to your location. There's a WeatherSTEM station in each one of Florida's 67 counties, and if you aren't close enough to a WeatherSTEM station, we encourage you to take a look outside at the clouds and also go to the National Weather Service to see what the current conditions are in your area. Our atmosphere has 4 distinct layers: the troposphere, the stratosphere, the mesosphere, and the thermosphere. Each one of these layers plays an important role in the Earth's overall atmosphere. The troposphere is where we find most of our weather and extends to about 10 miles above the Earth's surface. The stratosphere is where we find the ozone layer, and we can also see the weather balloons reach heights within the stratosphere. The mesosphere, about 30 miles up from the Earth's surface, is where we see things such as our meteors and even our rockets can reach these heights. Outside of the mesosphere is the thermosphere, the last layer of Earth's atmosphere. And this level of the atmosphere reaches up to 60 miles above the Earth's surface.
Time's up! The 4 layers of the Earth's atmosphere are the troposphere, the stratosphere, the mesosphere, and the thermosphere. The troposphere is where our weather takes place. Here you'll see clouds, rain, and snow. The stratosphere, our second layer of our atmosphere, is where you'll find our weather balloons flying. You'll also find airplanes flying in this area. This is also where our ozone layer is. The third layer of our atmosphere, the mesosphere, is where many rocks and asteroids burn up while traveling towards Earth. The final layer of our atmosphere is the thermosphere. This is a very thin layer, and it's where we find our space shuttle orbiting.
When meteorologists refer to upper air observations, they're referring to observations that are made above 5,000 feet in the atmosphere. This is where our weather balloon is going to be taking a bulk of its data. Above 5,000 feet in the atmosphere is where we have wind currents that can help steer the weather systems that impact our weather on a day-to-day basis. The weather balloons that the National Weather Service use have 3 distinctive parts. The first is the actual weather balloon itself. As you can see, it's a larger balloon than what you would typically buy in the store. It's made of a very special material that will allow it to expand out to a width of about 35 feet before it will actually pop. The next piece that is important is the parachute. This is attached to the weather balloon with a string and will help cradle the equipment or slow fall the equipment as it comes back down to Earth. The most important part of the weather balloon is this. This is the actual instrument package that we attach to the weather balloons. This instrument package is going to monitor the temperature, the relative humidity, and it also has a GPS located inside, which lets us know how high in the atmosphere it's going, the direction that it's moving, and where it can possibly land. From that, we are able to figure out what the wind speeds and the wind directions are high up in the atmosphere. Each one of these radiosondes or instrument packages from the National Weather Service can be retrieved, though the retrieval rate is really low. If you were to come across one of these instruments, it has a self-addressed stamped envelope where you could put the instrument inside the envelope and drop it off in the mail so that we would be able to reuse it again. However, a lot of these fall into the ocean, never to be retrieved.
The three main components of the weather balloons that we're sending up today and that the National Weather Service send up are the balloon itself, the parachute, and the radiosonde. The three main components of the radiosonde are the thermometer, which measures temperature, a humidity reader called a hydrometer, and a GPS, which allows the Weather Service to track where their balloon is. What do you think an exploding balloon looks like? It looks something like this.
WeatherSTEM weather balloon launch. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Now take a look at a different video. Notice with this one, since the balloon exploded on the ground, the balloon didn't break up into as many pieces. Also, the balloon didn't get as big as it would in the upper atmosphere, because there's more atmospheric pressure pushing down on it here on the ground. If you could send an object into the stratosphere, what would you attach to your weather balloon? How about some of these objects?
These weather balloons are launched twice daily across the entire globe. There are over 1,300 separate upper air observation stations across the entire planet. These are launched early in the morning and early in the evening, and globally coordinated so that we can get a snapshot of the atmosphere at any given time. Understanding what our atmosphere is like both in the morning and in the afternoon can help us better understand what our weather is going to be for the next few days. For global coordination, the weather balloons are released at the same time around the globe. We use Greenwich Mean Time in order to do that coordination. What that would mean is here on the East Coast, a weather balloon may go up at 8 o'clock in the morning. In the Central Time Zone, that balloon would go up at 7. In the Mountain Time Zone, it would be 6. And on the West Coast, they would put their balloon up at 5. That way, that snapshot that we take is taken across the globe at the exact same time. Now, interesting fact about the weather balloon is that they're either filled with helium or hydrogen. Hydrogen actually weighs less than helium. Helium weighs twice as much as hydrogen does. And they need to fill up these balloons with a powerful gas that's lighter to air so that they can complete the launch within 90 minutes of it being released on the Earth's surface. These weather balloons are released twice a daily regardless of what the weather conditions are. If it's sunny, if it's raining, if it's snowing, if the winds are blowing, the weather balloon is still going up. The only time that a weather balloon may not be released is if there is a thunderstorm in the area with lightning. If lightning happens around the time of the launch, it has to be postponed or scrubbed, meaning that it doesn't even go off. Here are some weather balloon facts. The National Weather Service has been releasing weather balloons since the 1930s. However, back in the late 1700s, people were attaching thermometers to kites in order to see what the temperature difference was between what they were experiencing at the surface and what they were able to get aloft. These weather balloons, as I have described before, can expand up to 35 feet in diameter when there is no pressure of the atmosphere pushing down on them. They can also reach heights over 100,000 feet, which is extremely high in the upper atmosphere. We're now going to show you a demonstration of what the weather balloon data looks like when it comes in from a weather balloon. This particular illustration is going to show you how temperature and dew point would map as it's going up in the atmosphere. So first we start with our weather balloon at the surface. And after we launch it, we start to see data coming in from the weather balloon. The white line is representative of the temperature as the balloon goes up in the atmosphere, and the red line is the dew point. Now, you might be a little concerned that as the balloon increases in height, all of a sudden the temperature starts to go back up. This is because the balloon has passed through the troposphere into the stratosphere and passed beyond the ozone layer. The air up there is very thin, and the ozone layer is what protects us from the UV exposure of the sun. Since the balloon is no longer protected by the ozone layer, it will be exposed to extra UV radiation, which can cause the temperature to increase. Now, as you will see later on, we will see the balloon have the same similar properties as it's being launched here at Buck Lake.
As the weather balloon leaves the troposphere and enters the stratosphere, it is no longer protected by the ozone layer, which protects us from the rays of the sun. Since it's no longer protected by the ozone layer, it is exposed to extra UV radiation, which causes the temperature to increase. This is why we will see with our weather balloon, the temperature decreases for a really long time and then all of a sudden begins increasing.
The data collected by the weather balloons is essential for weather forecasting. By collecting the information of temperature, dew point, and winds, we get a better understanding of what's going on in the atmosphere. Knowing these particular factors can tell us how moist the atmosphere is and if there's a potential for rain, or how dry the atmosphere is and are we going to have clear sunny days. Knowing the winds is important when it comes to steering the currents of storms and potentially if there are any impacts that might be on planes that are in flight. WeatherSTEM is a great way to introduce STEM education using weather concepts and how it impacts your students every day. There is one WeatherSTEM station in all of the 67 counties in Florida, and we even have some WeatherSTEM stations that are located outside of the state. You can find your WeatherSTEM station by typing the name of your county, so for example, leon.weatherstem.com, and choosing from the stations that are available. From there, you're able to get all of the data that is being pulled down from the local station that's located out on the school property. You're able to use the data that's collected by your WeatherSTEM station, and the data also feeds over 100 different resources that are available and aligned to Florida standards in the classroom.